Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on power dividers and direction couple. On my previous video, I actually have explained why three-port network cannot be matched, reciprocal, and lossless simultaneously. So this video, I'm going to explain when actually three-port network, they are only matched and lossless, but they give up the characteristics of reciprocal, then they will have a behavior like a circulator. So this video, the objective is going to explain what is actually a circulator and what happens when three-port only have the characteristics of match and lossless, and they actually given up the reciprocal. What will happen to this three-port network? This will be the part 3 series discussion on power divider and direction couple. So guys, if you're keen to know more about power divider and direction couple, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on power divider and direction couple. This is my email. If you have any question regards on this discussion, please drop me an email. If not, I strongly urge you guys to ask me the question through the comment. Okay, so this is because I hardly check this email. So guys, if you want to have a faster response, ask me through the comment, or maybe also suggest some topic for discussion through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe to this channel and turn on your notification bell. Okay, so let's discuss the 3 conditions of three-port network. The first condition that I'm going to discuss will be a matched three-port network. Okay, so what is actually a matched three-port network? So for example, when I input at port number 1, okay, I expected the power to come out at port number 2 and also port number 3. I do not want any of the power to come back at port number 1, okay, which is reflection. So hence for this, I actually need to be S11 need to be equal to 0. Same wise, when I actually input a power source, okay, at the port number 2, I anticipate that the power need to be appear at port number 1 and also port number 3. I do not want to have a reflection. So for this case here, I need S22 to be equals to 0. Same as this port number 3 here. So when the input is actually port 3, okay, again, I like the power to deliver to port 2 and also port 1. Nothing going to reflect back to port 3. So hence, S33 need to be equals to 0. And this is the outcome of the match condition. Next, okay, although for this video, okay, I'm actually not using this reciprocal, but I want to make this video complete. So let me explain the characteristics of reciprocal. Okay, so what is the meaning of reciprocal? For example, when I send an input at port number 1, okay, they basically deliver the power to port number 2. Again, when I actually has the same input power at port number 2, and I'm going to anticipate the same amount of power that will be delivered at port number 1. So basically, you can see that they need to have a vice versa relationship. So basically, this is the meaning of reciprocal. And when this happens here, you can see from here, so this is where the input, okay, which is at port 2, this will be where at the output. So when I actually put the input at port 2, I will get the output at port number 1. So they must be the same for this case here. So from here, you can see that I put my input at port number 1, my output at port number 2. So basically, this is the definition of reciprocal condition. And from here, you can also get the rest of the reciprocal condition. Okay, so basically with this, I actually can modify the S parameters. Early on is actually the match condition. So therefore, I have all this 0. And when it's also reciprocal, okay, then S12 and S21, they are the same. And I actually use just S12 to represent them. Same for this here. So S31 and S13 they are the same. So I just use S13 to represent. For this case, it's the same. S23 and S32, they are the same. So I just use S23 to represent it. So basically, this S parameters is used to describe match and also reciprocal. Okay, let's go into the last relationship, okay, for so-called lossless three-port network. Okay, so what is actually a lossless three-port network? So when I actually incurred input at port number 1 here. For example, my input is port number 1 here. Okay, I actually will expected the power to deliver at port 2 and port 3. So what is the meaning of lossless is the power at port 2 and the power at port 3, when I add them together, they must be exactly the same as the power at port number 1, which is where the input is. So basically, in short, okay, the power at port number 1 is going to evenly, or maybe they can even separate them, but I do not anticipate any loss. So in short, the power at port 2 and the power at port 3, when they are actually add together, they must be at the power at port number 1. Okay, so this condition here is slightly different from the previous video. Okay, I just want to keep this in mind. On my previous video, I actually have discussed, okay, when they are actually matched, reciprocal, and then lossless, all the 3 conditions all together. But for this condition here, is all mainly on lossless. Okay, so I believe you should be able to derive this equation. Okay, if not, look at my previous video, okay, for the explanation on this lossless triport network, the derive of this equation here. Okay, but okay, I don't think you have any issue. If not, okay, again, you can send through the comment to let me know. Okay, so next, okay, for this video, as I mentioned earlier on, okay, I mainly will concentrate when the triport network will be matched and lossless, okay, and they give out the characteristic of reciprocal. Okay, so this is what I have explained earlier on. So basically, this is under the match condition. Okay, so again, these are what I have discussed earlier on, which is on the lossless condition. Okay, so over here, okay, in order to make this triport network as a match and lossless, then I need to meet all these criteria here. So let me just do some consideration, okay, to meet all these criteria here. Okay, so for example, okay, I just need to make S12 equal to 0. Okay, when anything multiplied by 0, I will oblige by this formula. So in short, I just need S12 equals to 0. Okay, for this case here, I cannot let S21 to become 0. Okay, if it's also 0, which means that they are actually reciprocal. If you still remember, okay, they cannot be the same. So for this case here, if I let S12 equal to 0, then I can only let S23 become a 0. Like what I mentioned, if I let S21 equal to 0, then it will be reciprocal, and this actually disobey. Okay, if you still remember on my previous video, I have explained, okay, for triport network, it's almost not possible to have a match, reciprocal, and also lossless simultaneously. So therefore, for this condition, I will let S12 equals to 0, I will let S23 equals to 0, and I'll let just S31 to be equal to 0. So basically, this is my condition, okay, to criteria to make all these lossless condition. So next, after I have made this choice, all this becomes 0. Okay, I need to decide. Okay, so basically, when S12 is equal to 0, okay, you can see that my S13 I need to be equals to 1. So therefore, S13 is equals to 1. And when S23 equals to 0, you can see from here, this becomes 0. So therefore, my S21 need to be equals to 1. Okay, same as for this condition here, when S31 becomes 0, so therefore, my S32 need to be equals to 1. Okay, so basically, this will be my condition. So once I get all these conditions, okay, again, I can derive another set of S parameters. Okay, so basically, this set of S parameters will be matched and also lossless condition. Okay, so how can I do this? Okay, remember this is basically for match condition here. Okay, so now I need to continue my S parameters. So now S12, what will be S12? You can see that S12 is equal to 0. So therefore, this thing becomes 0. So it becomes a 0 over here. So S13, okay, S13 will be equal to 1, as you can see from here. So this one will become 1. So therefore, they become 1 over here. S21, what will we be? S21 will be equals to 1. So therefore, I will be equals to 1. This will be the same 0. So S23, okay, S23, I need to be equals to 0, as you can see from here. So therefore, S23 is equals to 0. As for S31, okay, S31 need to be equals to 0, as you can see from here. So therefore, S31 is equals to 0. As for S32, you can see from here, S32 need to be equals to 1. And therefore, okay, this set of S parameters ensure that the triport network will be matched and also lossless. Okay, so basically they give up the characteristics of reciprocal, but this triport network will be matched and lossless. Okay, I will come back to this set of S parameters on my next slides. Okay, but this is basically one of my conditions, okay, for the triport network to be matched and lossless. Okay, so next, Okay, so this will be the next condition. Okay, earlier on, I let S12 equal to 0, I let S23 equal to 0, and I let S31 equal to 0. This time around, I reverse. So I let S13 equal to 0, okay, S21 to become 0, and S32 become 0. So therefore, you can see that this is actually what happened over here. So again, if you still remember, when S13 becomes 0, okay, therefore I need S12 become a 1. Okay, when S21 become a 0, S23 need to become a 1. Okay, when S32 become a 0, I need S31 to become a 1. And then I guess you don't have any issue to find out these S parameters. I just quickly go through a few. So basically, these are all the match condition. So S12, you can see from here, okay, S12 need to be equals to 1, as you can see from here. So therefore, S12 equals to 1. S13, you can see that S13 is equals to 0. Okay, S21, you can see from here, S21 will be equal to 0. So therefore, this is 0. S23 need to be equals to 1. As you can see here, S23 belongs to 1, and therefore it become 1. S31 need to be equals to 1, as you can see from here, and therefore S31 equals to 1. And last but not least, okay, so-called this term here will be matched, and then this S32, okay, will be equals to 0, as you can see from here. So basically, this is another set of S parameters for a triport network to be matched and also lossless. So I put all these two S parameters over here. Okay, before I continue, guys, okay, if you have learned something from this video, okay, please consider to like this video. And for those who are new, okay, and you learn something from this video, please consider to subscribe and turn on your notification bell. Okay, so let me continue. Okay, so these are the two set of S parameters that I have derived earlier on. Okay, so basically these are all the two set of S parameters that I derived. So basically they are matched and also lossless. So I have derived these two set of S parameters, okay, for triport network to be matched and lossless. Okay, so basically this is a general S parameters. Okay, so what does all this S parameter means? Okay, so let's take a look on this since this is one. Okay, so basically this one here basically is S13. So what happened here is basically my input at port number 3 and my output at port number 1. So basically, in short, let me give you a graphical meaning here. So my input at port number 3 and my output at port number 1. So basically, this is S13. Okay, input okay at port number 3, output at port number 1. So basically, I have my input at port number 3 and output at port number 1. Okay, so another one term here basically is here. So basically will be S21, sorry. So basically the input will be at port number 1, output at port number 2. So basically again, okay, my input at port number 1 and my output at port number 2. Okay, so basically this S21 will be equals to 1. So therefore I will do only on this. And then the last one will be this term here, which is S32, which means that my input at port number 2 and my output at port number 3. So from here you can see that my input at port number 2 and my output at port number 3. Okay, so basically this characteristics actually is a clockwise circulator. Okay, what does this mean? Can you see here? Okay, basically my input here, I come out here. And when my input here, I come out here. And when my input here, I actually come out here. You can see that they actually has a clockwise circulation. So basically this is the condition for a matched and lossless triport network. Basically they have this lossless circulator. Okay, on the other set of S parameters which I have derived, okay, so basically this term here will be 1. So basically from here you can see that it's basically S12, which means that input at port number 2, output at port number 1. Okay, so basically you can see from here, input at port number 2, okay, output at port number 1. Okay, so the next term will be here. So basically will be S23, input at port number 3, output at port number 2. Okay, so basically input at port number 3 and output at port number 2. Okay, so basically this will be for this term here. And then last but not least over here, okay, will be S31, which means that input at port number 1, output at port number 3. Can you see over here? So basically this will be the input, this will be the output, this will be the input, this will be the output, this will be the input, and this will be the output. So basically you can see that they actually behave as a counterclockwise circulator. So in short, okay, basically this is the definition of circulator. Okay, whether is it clockwise or whether is it so-called anti-clockwise, okay, basically based on the possession, okay, which I have discussed earlier on. Okay, so with this, I think it is quite clear that when a triport network is matched and also lossless, they actually give up, let's say, the reciprocal, then they behave either as a clockwise circulator or if not, will be an anti-clockwise circulator. Okay, with this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now.